Good day everyone, you are welcome to today's class. In today's class, we want to look at analysis of Mexico City population density and the normalized difference vegetation index of the city. It is a GIS and remote sensing practical. So today, I want to take you through this very practical. And here is the instruction. All the data needed for this exercise are in the given folder. Use the data set to carry out the following exercise. The data include Mexico City boundary, population density, which is a raster, and also NDVI raster. And here is the exercise. Exercise 1. Create grid of 500 meters size around the data. So we have about 4 exercises here. So we are going to follow this exercise one after the other, and I promise I'm going to make it simple and sequential. All the data that I will use in this class and every other information will be made available, most especially for our YouTube channel members. And if you want to get all this data to practice, kindly join our membership and you have access to this data and other resources. So let's get started. So in this folder, I have all the data. So let me open it and show you. If I open it, all the data, everything I'm going to do will also be in this folder. The questions, the steps, everything will be in this folder. So this is the folder. So let's open any GIS software to carry out the exercise. In this class, we are going to use ArcGIS. So I'll open ArcGIS. So the first exercise is that we should create a grid of 500 meter size around the data. So and the data given include Mexico City boundary, population density raster, and NDVI raster. So let's go back to ArcGIS again. The first thing is to bring in the data. To do that, click on Add Data. Then navigate to your working folder. In this exercise, this is the folder, Mexico City population density and NDVI analysis. So I'll double click it. Here are the data. We have the Mexico City shapefile, NDVI Mexico, and the population density of Mexico. So highlight the three and click on Add. Yes, here is the data. Let me change this to hollow. Make it hollow, and I can change the color to red and click on OK. So here I have the population density and NDVI of Mexico, and the exercise before us is analysis of Mexico City population density and the NDVI. So the first exercise is to create a grid of 500 meter size around the data. So to do that, what you need a tool called Create Fishnets. The first thing, come to search. When you open search for Create Fishnets, or just search for fishnets. Then click on search. Here is the tool, which is Create Fishnets under Data Management tool. So click to open the tool. And here is it. So here, specify your output feature class. Click here and navigate to your working folder. So let's call this grid. Click on save. Then come here, this template extents. Click on the drop down and select the one of the data, and in this case we are going to select one of the raster. Click on it to select it. Then move down. Here we are to specify the cell size, and in the assignment or exercise we are told to create a grid of 500 meter size. So what we are going to do, enter the size here, 500 meter, 500, and also the cell height, 500. Then the number of rows. Now, this is what it means. The number of rows here is talking about if you are creating a grid size of 500 meter by 500 meter, how many of rows of this 500 meter grid do you want to create, and also how many number of columns. So the number of column and the number of rows. So here we have to specify the number such that it will cover the entire study area. So for example, I want to create about 120 rows, and then the number of column, I want it to be 100 column. So then scroll down. Here, make sure you check this create label point. This is very important. Then the geometry type, click on the drop down and click on polygon. Then click on OK. So what this one does is that it will create grids of 500 by 500 meter size across the entire data set. Yes, the fishnet has been created. Now let me uncheck the grid label and let me zoom in. If I click here and zoom in, you can see it has created a grid of 500 meter by 500 meter around the study area. Now what we can do, let's make it hollow for you to appreciate it. Here is the 500 meter by 500 meter grid line that has been created around our study area. If I make this one, let me change it to this color, so you'll be able to appreciate it. It has created a grid of 500 meter by 500 meter across the data set. So let me zoom to extent. So we have been able to create a grid of 500 meter size around the data. The next exercise, we are to extract the population density and NDVI value at 500 meter grid. What that means is this: the raster value of the population density and the NDVI value of Mexico City, we are to extract it within 500 meter interval, and that is the essence of creating grid lines of 500 meter size around our data. There is something we need to take note in exercise 3. The end of the exercise 3 says your attention is within Mexico City. So our attention should be within Mexico City. And if you go back to ArcGIS, here is Mexico City. Let me uncheck this. Here is Mexico City, and our attention is to be within this Mexico City. So what we need to do is to do the extraction within Mexico City. And how can we do that? So let's check the grid label. The grid label, if I zoom in, the grid label, they are points at the center of the grid line, that is 500 meter grid line. At the center of each 500 meter grid, the points put there is what we are going to use to extract the raster value at each of the points for the population density and also for the NDVI. And to do that, the first thing to do is to extract only the points within Mexico City. That is only, let me bring it up here. We want to extract the points within Mexico City. And to do that, this is what we need to do. Check the grid label. Yes. So to achieve this, we are going to use select by location. To do that, come to selection and click on select by location. Then check the grid label. We want our target layer is grid label. Check it. And the source layer will be the Mexico City. Then click on apply. It will select all the points. You can see all the points within Mexico City has been selected. So these are the points of concern for us. So what to do after you have selected the point within Mexico City? Right click the grid label and come to data, then export data, then navigate to your working folder, then give it a name. So this one we are going to call it Mexico Point. Then click on save and click on OK. Then click yes to add it. So now we can uncheck the grid label and uncheck the grid. So we are only concerned now with Mexico City and the points within Mexico City that we want to use to extract the raster value, that is the population density and the NDVI for Mexico City. So now let me uncheck this. We'll be able to extract all the values. So to extract the values according to the exercise, extract the population density and NDVI value at 500 meter grid. So to do that, come to Arc Toolbox, then come to Spatial Analysis tool, come to Extraction, and here you can see a tool here called Extract Multiple Values to Points. So double click it to open the tool. So what that tool does is that it helps you to enter multiple raster and extract its value to points. So our input point feature will be our Mexico point. Click here and select Mexico point. Then our input raster, we are going to input the population density and the NDVI. Click here and select population density, then NDVI Mexico. So we have selected the two raster. Then click on OK. Before I click on OK, let me show you something in Mexico City. If I right click and open the attribute table, you can see the field we have. We only have FID, shape and ID. So take note of that. By the time we run it, you'll see the changes. So now that you have input the two raster, click on OK. So it will extract the value of the two raster at each point to the table. Yes, it is done. Extract multiple values to point is successful. Now to verify, come to this point, right click and click on Open Attributes Table. Yes, you can see the raster value at each point for population density has been extracted, and also for NDVI has been extracted as well. So that is the exercise 2, that we should extract the population density and NDVI value at 500 meter grid. Now the next exercise is exercise 3. Using Pearson correlation, find the strength and direction of relationship between Mexico City population density and normalize different vegetation index. Then our attention is meant to be within Mexico City. So now let's go back to ArcGIS. To do that, what you need to do, we have about 2,939 points, of which the raster value has been extracted. So what to do is to copy it into Excel or any other statistical software to run the correlation. So what to do is to come to this table option, click on it, then click on select all. So it has selected all the points. Then come to this side, right click and click on copy selected. So because the number is much, it will take few seconds to copy it. Let it copy before you go to anywhere you want to paste it. Yes, it has copied it. Then go to Excel or any other statistical software. Then right click and paste table you copied. You can see I have copied the table which consists of the population density and the NDVI. So this one, let's label it well, population density. So, and this one is the NDVI. So let's save our data. Just click here. Let's save it as calculation. click on save. Now that we have saved it, let's go back to our exercise. We are to, using Pearson correlation, find the strength and the direction of relationship between Mexico City population density and the NDVI. So to do that, go back to Excel. So come to data and come to data analysis. If you can't find data analysis in your own Excel, in another video I've shown you how to enable data analysis in Excel. The video is in the description box. You can watch it as well. So come to data analysis. Then come to correlations. Here is correlation. Double click it. Then you will select here input range. Select population density and NDVI, the whole columns. You have to select it. And to do that, just click here and move to the end. So move to the end of the data and you see it has captured the whole data. Then here, check label in first row. Check it. Then our output option, you can specify the range or you allow it to be displayed in new worksheet. Then click on OK. When you click on OK, here is the result in a new sheet. So you can see the results. Let me expand this. So you can see here is the correlation value. The correlation value is showing a negative direction. So you can see the relationship between population density and NDVI in Mexico City is showing a negative direction. The relationship is negative direction. That means as population density is increasing, the NDVI value is decreasing. That is the direction. It's a negative direction. Then what is the strength? Looking at this, the strength is moderate. So we have been able to answer the third question, which says using Pearson correlation, find the strength. So the strength is moderate and the direction of the relationship is negative. As population density is increasing, then NDVI is decreasing. So that is it. And of course the discussion. So here we can just discuss the relationship that there is a negative direction or negative relationship between population density and normalized difference vegetation index in Mexico City. As population is increasing, the vegetation index is decreasing. So if you go back to ArcGIS, and let me close this. So you can see the value of, let me change the color ramp. Can change it to this color and click on OK. And this one also, we can change the color ramp to this and click on OK. And check this. So this is the population density, and the population density is more in Mexico City compared to outside. And then the vegetation index is higher outside than inside the Mexico City. So as the population is increasing, that is population density is increasing, the normalized difference vegetation index is decreasing. So this is the relationship and this is the discussion. So in this class, we have been able to analyze Mexico City population density and the normalized difference vegetation index in the city. So if you have any question, let's know in the comment section. And of course, these data sets and everything is available to members of our channel. And of course, if you also need this data set, buy me a coffee and I'll send it directly to your email. So I hope I have been able to do justice to this exercise. Thank you for watching.